So, hello guys, today we are going to solve the question that is the problem of the day on a leaf board. So, basically, question is given a count number of nice survey, right? So, given an array of integer nums and and an integer k, okay, and a continuous subarray is called a nice if there are k odd number on it, okay, and return the number of nice subarray. So basically, we have to count those subarray which contain the k odd numbers, okay. So in this case, if you can see, if we take the first four element, then it contain three ones, so it will be a one of the subarray and nice subarray, and this is the one of the nice subarray. So total there are two nice subarray. In this question, you can see only three, all three are basically even. So in this case, we have zero nice subarray, and here we have to count. Okay, so how we can solve this question? Let's open whiteboard and see. Mm, right. So what we will do here? Okay, so we are basically we have something like number 11211, right? 1 1 2 1 1. So basically we are concerned with something like odd and even. So why not we just represent the number as a odd and even? If the or number is odd, then we will represent as a 1, and if number is even, we will treat it as a 0. Now it is too simple because we have 0 in the form of 0 1, right? So how we can solve? Brute force approach is basically what we will generate all the sub arrays, and for that we count the how many odd numbers are present in the sub array, and yeah. So this is the brute force approach, and it will take lots of time, and because you can see the constants, its length of the array is basically 50,000, so it will take too much time. Okay, so how we can solve it efficiently? So for that, what we will do, we use something like prefix sum. Okay, so let's understand first. Okay, so just we will start from here. This is let's say our sum is initially our sum is basically 0, right? Okay, and yeah. Okay, so what we will do, we are starting from the we start from the 0 index, and this is 1. So what we will do, we add this 1 into our sum, and also k is given here, k is given is equals to something like 3, right? Means we need those subarray which has k odd elements. Okay, so we have k is equals to 3. So now we have converted the sum, converted the number in the form of 0 0. So when we are getting, when we get k is equals to 3, that means when our sum will be 3, then we can say it will be a one of the nice sub array. Okay, so now our sum is 1, so it is when we subtract the sum minus k 3, that is it will not be a 0. So it is not. So what we will do, we increase our pointer, and again we get 1, so we add this into our sum, so it will be 2. Now when we subtract 2 minus 3, so 2 minus 3, it is minus 1. So it is not a valid. So what we will do, we go ahead, and this time it is, this time this is 0, right? So still our sum is 2. So we'll move ahead, and now you can see sum our sum will be 3, and now when we subtract sum minus k, it will be 0. So we got the one of the nice survey. So increase our counter by 1. Now we will move ahead, and now our sum will be 4, right? So what we will do here, our sum is 4, but it might be possible if we skip the some element from the end of the subarray, the sum maybe the sum will be maybe the sum of that all elements in the subarray will be a 3. So for that, if we remove this element from the subarray, then sum will be basically 3. So in this case, we got the another subarray, right? So how we know that how we know, let's say remove these things, yeah. So our count will be increased by 2. So it is okay. But if we just consider the low pointer and how high pointer, and when our sum will be greater than 3, then what we will do, we will reduce the length of the subarray, right? So this is the approach, one of the approach. But what is the problem with this approach? If you consider this example, something like 2 2 2 2 2, then you will miss lots of subarray. If we have something 2 2 2 and 1 2 2 1 1 2 2 1 and 2 2 2. Okay, okay. So these are the this is the subarray. So what we are doing here, what we have first we have done something like we uh, represent the even as with 0 and odd as 1. So okay, just change it. So it will be something like that. Okay. So what will happen? Suppose your low is here and you will put the high here. So still sum is 0, so you will increase your high. Here sum is 0, and here basically given k is equals to 2. Okay, given k is equals to 2, right? So uh, okay, so here the sum is still basically 0. So now we will increase our high pointer, so it will be go there, and still sum is 0. Now we move ahead. Now our sum is 1. Okay, so but this is lesser than k, so we need one more odd number, right? So we move our head or high pointer. Now still our sum is 2. We again move our high pointer. Now still our sum is 2. Now again move, and here when it we reach this one, now our sum is basically 2, and our required means k is also given 2. That means we got the one subarray, right? So next thing is what we will do, now we will increase, and still the sum is 2. So our sum is not increased. Our sum is still 2, but we missed lots of subarrays. In what if we consider only this part, this is one of the subarray of with k is equals to 2, right? If we consider this part, if we consider this part, it is also a subarray, right? If we consider something like this part, if we consider something like this part, so lots of combinations means subarrays are there, but we missed that maximum subarray. So how we can handle this? So what we will do, we use something like prefix sum. Okay, so how we can use, so let's see. So let's see. Okay, so we have number something like uh, we have, okay, so we have a number something like what, okay, so we have 0 because even we are representing even number as 0 and odd number as a 1. So this is 0 0 0 1 0 0 1 0 and 0 and 0. Okay, and now remove these things. Okay, so what we will do here, we will maintain the prefix sum. So for that, when we so let's say understand this. Okay, so what we will do, we put one pointer here and we start iterating from left to right. Okay, and one more thing, we will maintain the here prefix sum. I am writing ps. So initially it is 0. Okay, and basically count is also 0. Okay, so what we will do, we just add this 0, and we know our k is basically 2. Okay, so what we will do, and what we will do here, let's say, okay, so here our when we am at this point, we add this, our sum is still 0. Okay, just move ahead, and now I am at here, now still our sum is 0, move ahead. Now I am at here, still our sum is 0, move ahead, and now we are at here, and now our sum is 1. Okay, sum is 1, so move ahead, and we reach here and sum is 1, we reach here and sum is 1, and we reach here, sum is 1. Okay, so one more thing, you can say how many zeros are appearing, means we have something sum as 0. It might be possible this sum 0 will help us in future. So when we are considering this, right, when we are considering this, it will be one of the nice survey. If we consider this, so important, there is a importance of 0 is too important. So we have to something keep track of the numbers, what how many times it appears previously. So for that, what we will do, we use something like map, right? And initially what we will do, initially we will store, because if suppose in future we will here when we reach here our sum is 2. So when we subtract the our k, right, the subtract the k from the sum, it will be result will be 0. So we need 0 in a map. For that we will maintain the that condition. So if we remove we subtract the k minus sum, it will be 0, then it is a nice array. So for that I have to initially uh, use this thing, that is 0 in a map. So what we will do now, now again we are going to traverse. So this time what we will do here, we are traversing from the start again. So here we have 0. So what we will do, we will check, we have sum is 0 and minus k. So we will check sum is 0 and minus k. So basically it is a minus 2. So this is not present. Minus 2 is not present in our set. So what we will do, we store the prefix sum. So prefix sum at here 0. So we will increase our pointer here by 2. Okay. So now we will go ahead, and now again we will calculate the prefix sum. Still prefix sum, we will add 0 into the prefix sum, and it is still 0. So now we will again subtract 0 minus 2, that is minus 2. This is not is equals to and this is equals to -2. So we will check -2 present in a set. No. So we will increase, we will just store the prefix sum. So prefix sum is still 0. So just increase this pointer, right? Now we will move, we will reach here. Now still our sum is 0. So when we subtract 0 -2, this is -2 is not present. So we will increase our this pointer to 4. Okay. Now we are reach here, and this time our sum is 1, and when we subtract 1 -2, it is -1, but -1 is also not present, so we will store the prefix sum. So why we are storing prefix sum? Because it will help in future. We will see how it will help. So now we will storing 1, and it appears once time. Okay. Now we will move ahead. Now again we will get 0. So sum is still 1. So when we subtract 1 minus k, that is 2, it will be still 1. So we will increase the 1 prefix sum value 1 again. Now we reach here, and again our sum is still 1. So we will increase our pointer. This k value means 1 is appear 3 times. It represents 1 is appear 3 times. The prefix with some prefix sum 0 is appear 4 times. Prefix sum with 1 is appear 3 times. Okay. Now we reach here, and now my prefix is basically 2. And when we subtract 2 minus 2, it is 0. So we will search, is 0 present in our map? Yes, 0 is present. And how many times present? It is 4 times. So just we increase our point counter by 4. You can see how many, you can see here how many possibilities you can see observe. You can observe. Let's change the colors. Okay. So why this is not working? Okay. So okay. So you can see one of the subset is this. Sorry, this, right? It you can see the sum of the element is basically 2, and we need basically 2. There is two odd numbers are there. Okay, this is one of the nice array. You can count this as second. Okay, you can count as this is as a third. Okay, and this is count it as a fourth. So we got the four subarray with k is equals to with some k is equals to 2. So how you can see how this prefix sum and map will help us to count the all the possible subarrays, nice subarrays, right? So now you can see here sum is actually 2, and when we subtract 2 minus 2, that is k s minus k, it will be 0. So this time we have a stores initially like 0 -1. This helps to count these kind of situation. If our sum is actually 2, and our k is value is 2, then we will subtract, it will give the 0. So in this case, okay, so here you can understand what is the why we are using that prefix sum and why we are using that map. Okay. So now we will move our pointer to here, and still we can say our sum is 2. So when we subtract 2 minus 2, it is 0, right? It is 0. That means that means we will check is 0 is present in our map. Yes, 0 is present. So what we will do? We will how many times it is present? It is present. Although I have missed something. When we are at here, okay. When we are at here now, our sum is basically 2. So we have subtracted it and counted, and also we have to increase our means store the prefix sum as well, right? So prefix sum here, prefix sum was 2. So we add into a set, that is 2 is appear once. Okay. Now we are at here, and now we add the sum. It will be sum is still 0, and when we subtract the k, it will be result is 0. When now we will look, uh, is 0 is present in our set? Yes. So we add 4 again, and it will be something like 8. Okay. Now we increase our pointer here, and this is still we got 0. So we will add the sum and 0 to the sum, that is 2 itself, and when subtract the k, so it will be still uh, giving us 0. So when again we check 0 is present in our set. Yes, it is present. So we will just count one more, because 0 is present 4 times, so we will increase it by 4, so it will become 12. Okay. And we just update our prefix sum. So prefix sum is still we have 2, so we will update it by 1 to 2. Now we reach at the end, and we will again check sum. When we calculate the sum, still sum is 2, we subtract the k, we get the 0, and still we will check if 0 is present in our map. Yes, it is present, and it is present as 4 times. Okay. So this is increased by 4, that is it will be something like 16, and we add this to, because sum is still 2, so we will update this by 1, so it will be 3. So uh, like this approach we can solve it. So here every time what we are doing here, we just calculating prefix sum, we subtract subtract the k from the sum, and result what is the requirements, we check if it is present in a map, then we add the frequency of that element in our answer. If it is not present, or although present or not present, we add that prefix into map, so that it will help in future. Okay. So uh, let's solve this. So what we will do, we just convert it this array into binary, in the form of binary, so it will help us for, we can easily solve it, right? So what we will do, we calculate the size basically, and n is equals to nums dot size, right? And what we will do, n is equals to nums dot size, and we iterate the this array over from left to right, and when we got even number, nums of I modulo 2 is equals to 0, that means this is even number, so we store just like nums of I is equals to 0. Otherwise we will store nums of I is equals to something like 1. So we have now the array in the form of 0 and 1. So what is our need? We need a map, so we will take unordered map for maintaining the frequency of and prefix sum. So int comma int, and let's say MPP. So what we are maintaining here in prefix sum? Here we are maintaining something like prefix sum and its frequency, right? Two things we are maintaining here. Okay. So yeah, and second thing, we need basically counter. So for storing the answer, right? And we need something like prefix sum that will store the prefix sum value. Okay. Now what we will do, we will start iterating from 0, from 0, and yeah, we're starting from 0, and what we will do, we add it into prefix sum. So prefix sum plus is equals to nums of I. Okay. And now what we will do, we will check uh, what is our requirement? What is our requirement? Requirement is basically if we subtract uh, k from the prefix sum, right? And we check if, okay, one more thing we missed. We have to store the zero prefix sum firstly 0 with frequency 1. Okay, so what we will do, we store it as a 1. Okay, so now we will check if mpp dot find that requirement, right? If is not is equals to mpp dot in, that means this is present in our map. So what we will do, we just increase our uh, counter by its frequency. So mpp of RAQ. Okay, and what we will do, what we will do here, hmm, we just add that prefix sum into our right, every time we are going to update it. Okay, this is done, and we will return our counter count, right? So I think we have done all these things, so let's run and see. Yeah, it's working fine, so let's submit it. Yeah, it's submitted successfully. Okay, so this is the solution. Okay, we will meet